So today we're talking about converting between degrees and radians. So you're going to learn a little bit about, first off, what a radian is, because a lot of you guys are probably used to the degree type of notation, but radians, if anything, were first, okay? Radians came before degrees ever were, okay? So first off, since you guys do know about degrees, let's talk about how many degrees there are in one radian. To convert from a radian to a degree, you would multiply 180 degrees divided by pi. Okay, you multiply your radian by 180 degrees divided by pi. So 1 times 180 over pi gives you 180 divided by pi degrees. Now, of course, you wouldn't want to leave it like that. You would actually want to divide 180 by pi. We are going to start incorporating the calculator just a tad bit into this particular unit. So you guys at home, if you have a calculator, go ahead and pull it out and do 180 divided by pi. You guys in the classroom, if you have a calculator on you, then go ahead and pull that out and do 180 divided by pi. And someone tell me what you get as an answer. $57.2. Okay, so my question, did you use 3.14 or did you use the pi button on your calculator? You did use the pi button? Okay. All right. So 57 point, give me a few decimal places actually. 295. Okay. So first thing, if you are going to be doing this and you are going to be using your calculator, we are beyond geometry level. We're at pre-cal now. We use the actual pi button on our calculators, whether it's scientific or graphing or even on our phones. We use the pi button. No more 3.14, okay? No more 3.14. Also, how we round when it does come to decimals, you need to round to 3 significant figures, okay? If you haven't taken physics or anything like that, what 3 significant figures are is you start with your first non-zero number and you count. So 5 is my first non-zero number, so that's my first significant figure. 7 is my second, 2 is my third. I'm technically going to stop it there, but I look at the number after the third significant figure to see if I round it up or if I keep it the same. Rounding rules apply. If it's 5 or more, you round up. If it's less than 5, you keep it the same. So this to 3 significant figures would be 57.3 degrees. Okay, so 1 radian is 57.3 degrees. If you look at a circle, right? How many degrees are in a circle? 360. A full circle is 360. That equates to 2 pi radians. Okay, that's about 6.28 radians. So if you were to break up a circle into radians, that's why pi, which is 3.14, it is 3 radians with a little bit left over to make up pi. Pi is 180 degrees. It is half of the circle, and that's why it's 3.14. That's how it all ties in together, okay? So 1 radian is equivalent to about 57.3 degrees. 180 degrees, which is also known as pi radians, is comprised of 3.1415 radians. And then a full circle of 360 degrees equates to 2 pi radians, which is about 6.28 radians. Okay? So a little bit of background there. How you convert from degrees to radians, okay? To go from degrees to radians, you want to, to go from degrees to radians, you want to multiply by pi over 180, and you get your radian. Now, the thing is here, is that you're not going to want to provide a decimal answer here. You want to actually divide 150 by 180 and reduce that fraction, okay? So it's basically like 150 over 1 times pi over 180. Well, that's 150 pi over 180. Then you reduce. If it ends in a 0, it's divisible by 10. That's going to be 15 pi over 18. 15 and 18 have what number in common? 3. So 15 divided by 3 is 5. 18 divided by 3 is 6. That's how you get 5 pi over 6. Okay? This is known as the exact radian. That's the non-rounded answer. That's equivalent to 150 degrees. But the second you put that in your calculator and you get a decimal, now you got an approximation. We are only looking for exact answers here, if at all possible. So to convert from degrees to radians, you multiply your degree by pi over 180. I know this is very blurry, but it should be on your paper. You guys should be able to see that. So I take 40 and I multiply by pi over 180. Well, that becomes 40 pi over 180. You've got to reduce your fractions. It ends in a 0, so it's divisible by 10. That turns into 4 pi over 18. Is there a number that goes into 4 that also goes into 18? 2. What's 4 divided by 2? 2. So this becomes 2 pi over 9. And it's as simple as that. Again, I multiply by pi over 180. That's 240 pi over 180. They both end in a 0, so they're both divisible by. And what number goes into 24? That also goes into 18. 24 divided by 6 is 4. And 18 divided by 6 is, so this becomes 4 pi over 3. Have I lost anybody in the classroom? What about online?
Oh, ma'am.
All right. To convert from degrees to radians, it doesn't get any harder. It just the numbers get bigger. Okay. So here we go. Both divisible by, both end in 0, so I can divide here. What number goes into 51? That also goes into 18. Ooh, testing your knowledge. 3. What's 51 divided by 3? So this becomes negative 17 pi over 6. Yes, you can have negative angles. You can have negative angles. And we're going to talk about that a little bit more in detail on Friday's class. Okay. And you can also have angles that are bigger than 360 degrees. We'll talk about that, how that's possible on Friday's class as well. 675 times pi over 180. Oh, this one doesn't end in the 0. But what number goes into 675 that goes into 180? 5. Don't forget about them old school rules. What's 675 divided by 5? Don't all go at once.
135.
135 pi. And what's 180 divided by 5?
36.
36. Is there a number that can go into 135 that can also go into 36? No, 2 can't, because 135 is not even. Can 3?
3.
3. So what's 135 divided by 3?
45.
45. And what's 36 divided by 3?
12.
Is there a number that can go to 45 and 12? 3 again. So we actually could have probably divided the original number on something maybe a little bit bigger to jump. But if we don't know, we do what numbers we do know. What's 45 divided by 3? And what is 12 divided by 3? So 675 degrees is 15 pi over 4. Okay? 390 is on you. 390 degrees as a radian is 13 pi over 6. Anybody not get 13 pi over 6? Good. Let's go the other way. From radians to degrees, what we already know is 180 over pi. 180 over pi. If your radian has a pi in it, then your pi's should cancel out when you convert that radian into a degree. Okay, so 3 pi over 5, when you multiply by 180 over pi, the pi's are going to cancel each other out, and you're just left with 3 times 180 divided by 5. That's how you get 108. Okay, for me, a lot of times I don't do keys and things like that with the calculator in front of me, so I really am using those skills of, instead of multiplying 3 and 180 to get a large number to divide it by 5, I ask myself, okay, 5 and 180 are divisible by the same number. It's 5. Okay, 5 divided by 5 is 1. 180 divided by 5 is 36. So really and truly, this is nothing but 3 times 36, and that's how we get 108. All right. This will be helpful too if you are taking the SAT non-calculator section, because you don't get a calculator on the SAT for a part of it. Knowing those different tricks to save you some time are helpful. So you multiply by 180 over pi to convert a radian to a degree. Again, if the original radian has a pi in it, the pi's cancel out. Okay, and to save a little bit more time, is 180 divisible by 4?
Yes.
What is 180 divided by 4? So then this becomes, instead of 7 times 180 divided by 4, now this just becomes 45 times 7, which we know is 315. Okay, same thing. I have a negative radian, so that means my result is going to be negative. I'm going to multiply by 180 over pi. My pi's cancel out. Does 12 go into 180 evenly?
By 15 times.
15. So this becomes 7 times 15. What's 7 times 15? So our answer is going to be negative 105 degrees because it was a negative radian to start with. To convert from a radian to a degree, you multiply by 180 over pi. I'm going to put this 5 pi over 1, and my pi's are going to cancel out. What's 180 times 5? 900. Again, I continue to multiply by 180 over pi. You guys go ahead and multiply 9 and 10 by 180 over pi and give me the degree. So online, what is this as an degree? Number 9.
80 degrees.
Classroom, you confirm? Wonderful. Okay, so then classroom, what's number 10? 420. Online, do you agree?
Yes.
Wonderful. So again, to go from radian to degree, you multiply by 180 over pi. If you go from degree to radian, you multiply by pi over 180. Now, the one thing you do need to be aware of with radians, remember that radians can either be written like so with the pi, or they can just be written as a number, okay? If it's just written as a number, this stands for 3 radians. That means whatever number was in front of pi, when they multiplied it together, it ended up just being 3 as a whole number. So if you end up with something like 3 radians or just 3, don't let that throw you off. You're converting it to a degree, so again, you multiply by 180 over pi. In these cases, pi is not going to cancel out, okay? So this is where you'll actually have to multiply straight across, and then you'll get a decimal approximation for the degree. So in these cases, the degree is not going to be a whole number. It's going to be a decimal. Okay. So can someone real quick do 540 divided by pi in their calculator and tell me what degree this is? Should be less than 180. I know that much because 3.14 radians is 180 degrees.
It's like 171.88.
So if I wanted to round this to 3 significant figures, practicing our rounding, remember you start with your first non-zero number, which is 1. Then you count. This is my second. This is my third. So I stop here, but that 8 is going to cause that 1 to do what? So 3 radians is about 172 degrees rounded to 3 significant figures. Okay. And if anything, that's always how I want you to round. So if we have like a SOHCAHTOA problem and it doesn't tell you how to round, give me 3 significant figures. That's what I want. Any of y'all who plan to go into IB, it's always 3 significant figures. If you're not, still 3 significant figures. All right. So checking out these first 5, yes, for 1, 3, and 4, we were converting to radians. So we multiply by pi over 180. For 2 and for 5, we were converting into degrees. And so we have those respective answers. Let's look at the last 5. So for the first 3, yes, we were converting to degrees. For 6 and 7, and then for 8, we're converting to radians. Now for 9, you say you left it at 12.5 pi over 180, okay? The one downside about this is 12.5 is actually a fraction. So you got a fraction within a fraction. So you don't want to leave it that particular way. 12.5 is the same thing as saying 12 and 1/2, correct? What is that as a improper fraction? 25 over 2. So technically you have 25 over 2 pi over 180. How do you simplify that? A little louder. Keep, change, flip. Yeah, so I keep the numerator. I change that division to multiplication, and then I flip that denominator, so then it becomes this. So now when I multiply straight across, or better yet, is there a number that goes into 25 that also goes into 180? So this becomes 5. And what's 180 divided by 5?
36.
So our most simplified answer is going to be 5 pi over 2 times 36, which is 72. So 5 pi over 72 would be your most simplified answer, okay? And the last one, number 10, online.
Pi over 90.
It would, we gotta be careful. 2 is actually a, it's a radian, so we're gonna end up with a decimal. So we're actually going from radians to degrees, so we need to multiply this by 180 over pi. So it's not 2 degrees, otherwise we would have had that like little degree symbol. It actually represents a radian. So we're gonna multiply it by 180 over pi to get 360 over pi, which is about
115.
Did you round it right?
No, 115.
Oh, 115. Did you round it right? Sure.
Yeah.
3 significant figures.
And then you came up with 114 and like 114.5.
Okay. So yes, we got to be careful on these. If it's just the number without the degree, they're talking about a radian. So then you'll want to convert from radian to degree. But that's it.